Did you know that you're always moving at an incredible speed, even when you're sitting perfectly still? That's because our Earth is constantly in motion within the vast expanse of the solar system. This cosmic neighborhood of ours, with its infinite mysteries and marvels, is always on the move, and we, as terrestrial residents, are along for the ride, spinning and orbiting in a ceaseless cosmic ballet. So fasten your seatbelts as we embark on this cosmic journey and unravel some of the most fascinating facts about our solar system. The Sun, the star at the center of our solar system, is so huge that it could fit over 1 million Earths inside it. Imagine that for a moment, 1 million Earths. That's like filling up a beach ball with grains of sand. Each grain represents our Earth, and the beach ball? That's our Sun. Now that's something to wrap your mind around, isn't it? The Sun's diameter is about 109 times that of Earth's. So, if you were to line up Earth's edge to edge, you could fit more than 100 of them across the Sun's face, and yet, despite its enormous size, the Sun is just an average-sized star in the vast universe. The Sun's size is mind-boggling, isn't it? But that's not the only thing that makes our solar system special. Mars, the red planet, is home to the tallest volcano and the deepest, longest canyon in the solar system. Let's take a closer look at these magnificent features. First off, Olympus Mons, this gigantic shield volcano, stands approximately 13.5 miles high, nearly 3 times the height of Mount Everest, Earth's tallest peak. This towering volcano didn't just appear overnight. It's a result of millions of years of lava flows piling up on each other. Next, meet Valles Marineris. It's not just a canyon, but a sprawling canyon system that stretches over 2,500 miles across the Martian equator. About 10 times longer than our Grand Canyon, it's so vast that it covers nearly a quarter of Mars' circumference. These colossal structures give us a glimpse into the dynamic geological history of Mars, showcasing the planet's active and tumultuous past. Mars truly is a planet of extremes. Now let's move on to the next exciting fact. Did you know that Venus, our solar system's second planet, rotates in the opposite direction to most other planets? That's right, while most planets in our solar system, including Earth, spin from west to east, Venus likes to dance to its own tune. It rotates from east to west, a phenomenon astronomers call retrograde rotation. Now you might be wondering what caused this peculiar spin. Well, scientists have a few theories. One of them is a gigantic asteroid impact that could have reversed its rotation. Another suggests that Venus' dense atmosphere could cause a tidal lock with the Sun, leading to its unique spin. This unusual rotation has some interesting implications too. For starters, a day on Venus is longer than a year. It takes Venus 243 Earth days to complete one rotation, but only 225 Earth days to orbit the Sun. Venus certainly likes to do things its own way, but what about the other planets? The largest planet in our solar system, Jupiter, has a storm that's been raging for at least 300 years. This storm, known as the Great Red Spot, is an anticyclonic storm that's larger than our own planet, Earth. It's a swirling mass of gases and clouds, spinning with the might and force of a hurricane that's 3 times the size of our home planet. Now, just imagine that. An Earth-sized hurricane on Earth would be disastrous, but on Jupiter, it's just another day. The Great Red Spot has been observed by astronomers for centuries, and it's one of the most prominent features of Jupiter's thick, gaseous atmosphere. The storm's iconic reddish hue is thought to be caused by complex organic molecules, phosphine and sulfur compounds. It's a storm unlike anything we've seen on Earth. Jupiter's storm is a testament to the dynamic and turbulent nature of our solar system. Saturn, the second largest planet, is most famous for its spectacular ring system. These rings, viewed from afar, create a breathtaking celestial spectacle, but let's delve a little deeper. Composed primarily of countless chunks of ice and dust, the rings of Saturn aren't a solid structure, but rather a collection of particles, each circling Saturn on its own path. Their discovery traces back to the 17th century, credited to the Italian astronomer Galileo Galilei. However, it was only later, with the advent of stronger telescopes, that Dutch astronomer Christian Huygens correctly identified them as a disk encircling the planet. As we learn more about these rings, we find that they are not just beautiful, they are dynamic and complex. They vary in size from tiny dust-sized icy particles to massive chunks as big as mountains. Saturn's rings are a beautiful mystery, a testament to the wonders of our solar system. On Neptune, you'd experience winds like nowhere else, reaching speeds of over 2,000 kilometers per hour. Talk about an intense breeze. This eighth and farthest known planet from the Sun in our solar system isn't playing around when it comes to weather. These supersonic winds are faster than the speediest commercial jet and could easily outpace a bullet train. Now you might be wondering, why are Neptune's winds so incredibly fast? Well, it's a combination of Neptune's cold temperatures and its rapid rotation that create these extraordinary conditions. The planet rotates once every 16 hours, creating an intense Coriolis effect that causes winds to whip up to these mind-boggling speeds. It's a world of extreme weather, where the winds are always howling and the storms are incredibly violent. And yet, there's a sort of wild beauty to it all. Neptune's winds are truly superlative, showing yet another extreme of our solar system. Let's make a slight detour to the smallest and innermost planet in our solar system, Mercury. Although it is the closest planet to the Sun, Mercury is a realm of stark contrasts. The planet's sunlit side is scorching, with temperatures that can rise to a staggering 430 degrees Celsius, which is hot enough to melt, lead to a pool of molten metal. However, this should not deceive you, as Mercury's dark side narrates a contrasting tale. Here, temperatures can plummet to a bone-chilling minus 180 degrees Celsius. This dramatic contrast is a result of Mercury's wispy atmosphere, which fails to retain heat. Additionally, the planet's leisurely rotation contributes to this drastic temperature variance, as a single day-night cycle on Mercury extends for approximately 176 Earth days. This implies, if you were to stand on Mercury's surface, you would endure a blistering and protracted day, followed by a frigid and equally drawn-out night. Mercury's ice-filled, permanently shadowed craters further add to the planet's list of paradoxes. As we delve deeper into the mysteries and extremes of our solar system, Mercury's wild temperature swings and icy craters act as a symbol of the diverse and intriguing conditions that can be found on these heavenly bodies. As we continue this journey of exploration, we are reminded that the cosmos always holds more secrets to uncover and understand. After the extreme temperatures of Mercury, we now turn our attention to the seventh planet from the Sun, Uranus. This intriguing gas giant stands out our solar system due to its distinctive axial tilt. Instead of rotating like a traditional spinning top on its axis, Uranus performs a remarkable sideways spin. Its axis of rotation is tilted at an extreme 98 degrees, making the planet to roll around the Sun, literally on its side. This unique tilt of Uranus leads to extreme seasons that each last a staggering 21 years. During the summer and winter solstices, either the North or South Pole is pointed directly at the Sun, leading to 42 years of continuous sunlight or darkness at a stretch. The sideways spin of Uranus is believed to be the aftermath of a massive collision with an Earth-sized object in its distance. Such a powerful impact was needed to effectively knock Uranus its side. This sideways spin not only adds another layer of mystery to our solar system, but it also serves as a stark reminder of the violent past that has shaped these celestial bodies. As we deeper into our cosmic journey, we are continually reminded that each planet holds its own unique and intriguing secrets. The dwarf planet Pluto, once the ninth planet in our solar system, has an icy, heart-shaped glacier that's the size of Texas and Oklahoma combined. This fascinating world, nestled in the outskirts of our solar system, is home to some of the most intriguing features that defy our understanding of planetary science. Beyond its icy heart, Pluto's surface is a diverse landscape of mountains, valleys, and plains. This icy world also has a thin atmosphere that expands when it comes closer to the Sun and collapses into frost when it moves away. The constant ebb and flow of this atmosphere creates a dynamic and ever-changing environment. And one of the most exciting discoveries about Pluto is the possibility of an underground ocean. Beneath its icy surface, scientists believe a vast ocean of water might exist, which could potentially harbor life. Despite its small size, Pluto is full of surprises, just like every other part of our solar system. Between Mars and Jupiter lies the asteroid belt, a disk populated by millions of asteroids. This vast cosmic carousel of space debris spins a story of our solar system's formation some 4.5 billion years ago. Imagine, if you will, a ring of rocky remnants, leftovers from the birth of planets. This is the asteroid belt, Positioned about 150 million miles from the Sun, the asteroid belt is far from a dense field of tumbling space rocks. In fact, the average distance between asteroids is about 600,000 miles. That's over 2 times the distance from the Earth to the Moon. These asteroids, ranging from tiny space pebbles to objects hundreds of miles in diameter, serve as a cosmic library, preserving the primordial material that helped form the planets. They're like the building blocks of our solar system, frozen in time. The asteroid belt might seem chaotic, but it plays a crucial role in shaping our solar system. As we've journeyed through the solar system, we've discovered some truly amazing facts. We've journeyed from the Sun with its incomparable size that puts everything else to shame. It's a fiery behemoth holding us all in its powerful gravitational grip. Then we've entered to Mars, the red planet with towering mountains that dwarf even the tallest peaks on Earth. Venus surprised us with its unusual rotation, spinning in the opposite direction of most planets. It's a world turned upside down, challenging our understanding of planetary formation. We then traveled to Jupiter, home to a massive storm, larger than our entire planet. It's a swirling, churning cauldron of gas and wind, a testament to the planet's volatile nature. Next stop was Saturn, famed for its stunning rings, composed of countless particles of ice and rock. They are a celestial spectacle unlike any other. We braved Neptune's supersonic winds, the fastest in the solar system. Despite the intense cold, these winds whip around the planet at breakneck speeds. Finally, we reached the icy world of Pluto, a dwarf planet at the edge of our solar system. It's a frozen frontier, a testament to the extreme conditions that exist in the outer reaches of our celestial neighborhood. And let's not forget the asteroid belt, a chaotic tumble of rocks and debris, remnants of a planet that never formed. Our solar system is a marvel of cosmic phenomena, each fact more fascinating than the last. As we continue to explore, who knows what else we might discover.